Hello guys, welcome back. And we have this problem. This is the first problem. If you have not tried this problem, do try this out. So let's start the problem. So this problem demands a really interesting observation, and that observation just requires you to find an dig your high school mathematics knowledge, which tells you that. So can you just tell me like what this formula looks like? And if you think about it, and if you pause this video and think about it for some time, you will realize something interesting. If I tell you, the hint is that this formula is like this: that tan x plus tan y. I think this is a bit, yes. So I think tan x plus tan y. Let me make it a bit bigger, by 1 minus tan x tan y. If you remember, this is equal to tan of x plus y, right? And you can see that same pattern emerges over here magically, and we will use this idea. One interesting idea is that tan, like unlike sine and cosine, tan can take minus infinity to plus infinity values. So it's like a one-to-one function, bijective function, the real number line to the real number line, tan x. So not a one-to-one, like minus pi by 2 to plus pi by 2. I mean, minus pi by 2, minus pi to plus pi. Yeah. So if you can see minus pi by 2 plus pi by 2. I'm so sorry. So yes. So if you can see it over here, if we can sort of get an idea that okay, if we can replace an by tan theta n. So let's replace an by tan theta n. Why we can do that? This step is super important to justify because tan can take values between minus infinity to plus infinity. Remember this, okay? And this theta n is something interesting. This theta n is less than 180 degree and greater than 0. Remember this, okay? So it will matter afterwards. So theta n is less than, because after that it starts repeating itself, okay? Tan x. Okay, so if we apply this, you can find out that n can be replaced by tan n, tan theta n. So if you replace it over here, what will you get? This is tan theta n plus tan theta n plus 1 minus tan theta n times tan theta n plus 1. So you get this is equal to an plus 2, which is equal to tan theta n plus 2. Okay, and also from this we get that it's equal to tan theta n plus theta n plus 1. And therefore we get the relationship that tan theta n plus 2 is nothing but tan theta n plus 1. And this is super important. This is super beautiful, rather, I should say. Okay, and we get this result over here. So what we are doing, the first step is replacing an by tan theta n, and we are getting this a very beautiful result over here, that tan, it's in terms of tangent function. So the question there for us, that what is this like a of 2000 and n, rather what is tan theta 200 n? So therefore we'll try out what theta is, what theta and how does theta, how do the theta n behave. And if you observe over here, if you see this, it's just nothing but tan 45 degree, and here it's nothing but tan what 30 degree. So you get pi by 4 and you get pi by 3. Okay, or let's do it at 45 degree and 30 degree. So what do you get over here? The theta 1 is 45 degree, the theta 2 is 30 degree, okay, and theta 1 is this, theta 2 is this. Then theta 3 will be what? Sum of this to 75 degree. Theta 4 will be what? Sum of this two. That is 105 degree. So if you observe over here, both of them are multiples of 15. So you can just write it as 15 times 3, 15 times 2, it's 15 times 5. Okay, it's 15 times, therefore 7. So you get this scenario over here, that it's 3, it's a Fibonacci series in some sense, 3, 2, 5, 7, okay, and it continues. and then it will be 12. But remember that it should be, remember that if it goes over 180 degree, it should be 180, that minus 180 degree, okay? So let's say here, let's check it, it's theta phi, which is equal to 180 degree, okay? So it turns out to be 0 then, right? It turns out to be 0, because it's 15 into 180 degrees is 0 in some sense. And again, it starts. Okay. So we can go till 15 up to 15 into what? 180 degrees is equal to 15 into 12. So we will get 12. So 3, 2, 5, 7, then 12 comes, which is equal to 0, and then again 7 starts. Okay. And then again 7 starts, and then again 7 starts, and then we get 14, which is minus 12, which is 2. So we see that we are adding this modulo of 12. Modulo of 12 means we are seeing the remainder when divided by 12. And therefore we get this, that 3, 2, 5, 7, 0, 7, 7, 14, that is 2, and then 9, and then 11. Okay. And then we get 20, and modulo 12, we are seeing the remainder, and that's turned to 8. And then 11, 8, 19, again remainder after dividing by 12, 7, and then 15, then remainder 3, then 10, remainder 13, 1, and it goes on. And let's see how much it goes on. Okay, let's see how much it goes on. It's a really interesting stuff. And 11, then 12, which is again 0. Okay, and then 11 over here. Okay, and then again 11 over here, and then it's like this, going like this. Okay, I'm going in a spiral maybe. And then 22, that is 10, because we are seeing the remainder when divided by 12. And then we are getting 21, then 9, it's 19, then 7. Okay, it's 19, then 7, and then it's 16, then 4. And then it's 11, it's totally fine now. Then it's 3. Okay, and then it's again 2, and then it's 5. Okay, and you see something coming up? Do you see these things coming up? 3. Okay, let's write like literally, yes, 3, and 3 are come here it comes up, and then 2, here it comes up again. Okay, and then 5 comes up. So we have found a period, we have found the pattern, we have found the cycle out here. And we see it's 7, 0, 7, 2, and let's count the cycle. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And again it's repeating. So the cycle length is 24. And now you know that we need to find 2009. Cycle length is 24. So we divide by 24. How many such 24s are there? So divide by 24, and we divide by 24, and we get that, I think we get that it's equivalent to 2009 divided by 24. I think it's equivalent to 17. The remainder is 17. The remainder is 17. So you can tell that it's nothing but a of 17. And let's calculate a of 17. A of 17 is 1, 2, 3, 4, 5, 6, 17, 0. So therefore, it's 0 over here. And you have got, it's a perfect. A very beautiful sum, which tells you, first of all, you have to remember the basics of your high school mathematics knowledge, and how you can use this tangent function and the bijective function s to replace an by tan theta. And this is the most important step. And then we see a beautiful pattern emerging up. And don't lose hope, because the long pattern, you may see that, you may feel that there is not a pattern, but there is actually a pattern. Otherwise, the problem couldn't be solved in real time. And these are the things you need to be having a lot of patience, and it's a really beautiful sum. So stay tuned and perfect, stay ablaze. And if you're willing to look into our crash courses and mock tests, do check out our preparation links below. And don't forget to join the WhatsApp group of ours, where we hold quizzes and we discuss solutions. We have a lot of interesting discussion among the best of the students out there. So all the best, guys, and yep, See you in the next video. Stay tuned and stay blessed. Don't forget to subscribe to our channel and like it and share it to your friends.